To analyze the high priest's breastplate objectively, we strip away historical mysticism, treating the object purely as a 12-node matrix of chemical data. Translating the 12 stones into modern mineral identities produces a 3x4 array built largely from silicon and oxygen, punctuated by elements like copper, zirconium, and beryllium. We are testing if this array contains a random assortment of materials or a deliberate, rule-governed internal grammar. Standard pattern matching is unreliable here. The human brain naturally suffers from pareidolia, the tendency to connect loose, thematic dots to support a pre-existing bias. To extract objective truth from this matrix, we apply an uncompromising algorithmic filter designed to destroy weak connections and separate structural signal from statistical noise. The governing physics of this entire analytical program is a rule called compression. Compression opposes the human instinct for broadening. Broadening expands possibilities and relies on loose resemblances. This is a failure state and is immediately eliminated. The algorithm mandates sharpening. A pathway only survives if it mathematically reduces ambiguity, forcing data into a tighter mapping. The internal pattern must get smaller, cleaner, and more exact under immense pressure, or the algorithm completely discards it. We execute this compression rule across 4 distinct analytical runs. First, blind compression, then directed replication, a composite reframe, and a strict falsification test. Any data pathway surviving this algorithmic crucible represents a mathematical and structural reality native to the object itself. Run 1 is blind compression. The algorithm starts without any predetermined hypotheses, testing only how the native chemical nodes interact. The algorithm identifies a background baseline where the majority of the nodes form a common silica backbone. Against that background, 4 specific anomalous nodes stand out as active sites. These interruptions are distinct. Node 4 acts as a copper phosphate gateway. Node 6 opens a light element corridor. Node 7 introduces a heavy zirconium anomaly with traces of uranium and thorium. And Node 10 presents a beryllium-bearing receiver host. The algorithm translates this architecture into grammatical movement. As it tests the connections between these active sites, it is forced to choose between a light chemical pathway and a heavy chemical pathway. The possibilities rapidly collapse. Alternative pathways, like an exchange route through zirconium borides, are ruthlessly pruned for failing the exactness test. A single surviving vector emerges. The data dictates a precise movement from the heavy uranium and thorium anomaly directly into the beryllium-bearing receiver. The output of Run 1 is a highly specific host and substitution rule, isolating a uranium-beryllium system. Run 2 is directed replication. The algorithm intentionally attacks the Run 1 baseline by injecting 3 external variables to test the integrity of the system. The first attack introduces thulium, a heavy rare earth element that is a geologically legitimate extension of the matrix's heavy anomaly stone. The compression rule rejects thulium. Introducing it broadens the heavy corridor, rather than locking it into a more precise rule. It is blocked from the core. The second attack tests sulfur and the chalcogen family. Unlike thulium, this chemistry is natively present inside one of the matrix nodes. Sulfur remains mathematically viable for several stages, but it fails to rival the exactness of the uranium-beryllium spine. It is mathematically subordinated and discarded. The third attack, testing symbolic or religious resonances like the urim and thummim, is explicitly banned at the door. Symbolic echoes cannot steer a material's grammar. The uranium-beryllium output survives targeted algorithmic pressure and the pruning of false positives, emerging as the dominant structural signal. Run 3 is the ontological reframe. The matrix is redefined not as floating nodes, but as stones embedded in a continuous gold matrix. Treating gold as a native boundary adds realistic interface constraints to the simulation. The gold-beryllium interface survives the longest before being absorbed into the baseline syntax, reflecting real-world intermetallic behavior. Run 4 executes the final falsification test. We substitute academically credible alternative translations for specific stones to see if the output survives. We swap the primary load-bearing nodes. Replacing zircon with amber removes the heavy anchor. Replacing beryl with topaz removes the beryllium receiver. Altering these specific nodes completely destroys the topological spine. Without its exact anchor and exact receiver, the machine breaks. We then swap contextual nodes, replacing lapis lazuli with sapphire and topaz with peridot. The core structure remains perfectly intact. The alterations change the contextual description of the grid, but the central vector line is undisturbed. The matrix is selectively dependent. The extracted signal is mathematically bound to these exact chemical inputs, ruling out the possibility of the algorithm simply generating forced artifacts. After 4 stages of algorithmic compression, the final output is the precise pair of UB13, leading to U1X Thor X B13. This identifies a uranium berylide host and an exact thorium-substituted continuation on that same host. This identifies a class of materials known as heavy fermion superconductors, where electrons behave as though they are far heavier than usual due to intense internal interactions. Thorium-doped UB13 is famous in condensed matter physics for a specific anomaly. When cooled to ultra-low temperatures, it exhibits a debated double transition phase. For a narrow composition range, the system seemingly reorganizes its ordered phase, or superconducting state, twice as the temperature is lowered. The algorithm converged exactly on the composition line of one of the most puzzling, unresolved boundary conditions in modern physics. We must maintain strict epistemological boundaries regarding what this analysis can and cannot claim. This data does not prove that an ancient author possessed advanced scientific knowledge, nor does it prove deliberate encoding by the artifact's creators. The analysis does not claim to have solved the physics of UB13. What it does is map the exact structural architecture of that material from an entirely unexpected historical dataset. What the study empirically proves is the architectural reality of the data matrix itself. When a disciplined, algorithmic elimination grammar is applied to this 12-node historical matrix, it reliably extracts a physically serious topological spine. It distinguishes core from boundary and chemistry from symbolism. While the human intent behind the artifact remains a historical mystery, the precise chemical pattern hidden within it is an empirical reality that survived the ultimate crucible of logic.